Good evening everyone, this is Pavan Kumar. Welcome to ACE Online. So today we are going to discuss about the revision series for the Geotechnical Engineering regarding to the SSC JE examination. So first of all, the SSC JE examination is a Group B non-gazetted government post. It offers a very handsome salary and with a basic pay scale of 35,000, around 35,400. And if you see based upon the type of city you're going to get posted, you may be drawing in-hand salary of 53,000 to 62,000. So there is a very good opportunity for all the people in the entire India who are willing to go for the government examinations. So in this session, we will try to cover what are the questions, what is the weightage and what is the syllabus that required from the geotechnical point of view to the SSC JE. So first of all, if you see the syllabus, the geotechnical engineering is nothing but over here, it is termed as a soil mechanics. Though it is given as a n number of concepts, we have speculated that into different chapters and we have provided through ACE online videos. So if you have already subscribed to the ACE online videos, you might be seeing how well we train for the SSC JE and other state service and central service examinations. So if you see, first coming to the soil mechanics, the origin of soil, this origin of soil we have delivered as chapter number 1, and then phase diagram, definitions, void ratio, porosity, degree of saturation, water content, specific gravity, unit weights, density index and interrelationship of different parameters. So those things we discussed in chapter number 2. So as properties of the soil, physical properties of soil. And then we discussed about the grain size distribution curves and their uses, the index properties of soil, Atterberg limits. These Atterberg limits index properties as a separate chapter. That chapter name itself as index properties. And then the soil classification and plasticity chart, that itself we classified as a classification of the soils. And then the permeability of soil as a separate chapter. So in the permeability of soil, quotient of permeability, how we are going to determine the quotient of permeability and what are the different type of aquifers, confined and unconfined aquifer. So that is one chapter in permeability. And then we discussed separately the chapter as effective stresses. So what are the various stresses? What is the total stress? What is the pore water pressure? What is the effective stress? So that has one separate chapter. And then we discussed about the seepage pressure. In that seepage pressure, we discussed about the quicksand condition. And then we discussed about separate chapter as a consolidation of the soils. So that is separate chapter as a consolidation. In consolidation, we discussed about the principles of the consolidation, degree of the consolidation, pre-consolidation pressure, what are the different type of soils normally consolidated, pre-consolidated, over-consolidated. So whatever the E log, P curve, computations, and everything up to this point, see from the consolidation to the ultimate settlement up to this point, that entire topics that covers in one chapter known as consolidation. And then we discussed about the shear strength of the soils. So in the shear strength, we discussed about different tests, how to determine the shear strength, which is a direct shear test and then vane shear test. The vane shear test is the one that we do in the field. Triaxial test, that's the most commonly used lab test to determine the shear strength. And yeah, so from here to here, we discussed about the shear strength. So then there is one more chapter known as a compaction. In compaction, how we do the compaction in laboratory, how we do the compaction in the field. So laboratory compaction test, maximum dry density, optimum moisture, this all comes under compactions. So up to this point, whatever this is a soil mechanics actually to say. And from the foundation engineering also, they have given little bit extra portion. From foundation engineering, they asked questions from earth pressure theories. So in earth pressure theory, we discussed about active state, passive state and at rest condition. And then bearing capacity of soils. In bearing capacity of soil, plate load test and standard penetration test. From the foundation engineering, regarding to the SSC JE syllabus, it is very less. Because in foundation engineering, there is a stability of slopes, no question has been asked. There is a pile foundations, very less question, at least one question has been asked. There is a well foundations, nothing regarding to well foundations. Kaizens are there, well foundations are there, dewatering techniques. Nothing was there for the SSC JE. I say to crack the SSC JE, it is very easy for you if you have a basic knowledge of a civil engineering, either in your diploma or in your B.Tech. So this is about the syllabus. And now let's see the weightage of the geotechnical engineering in case of the SSC JEE of the previous examinations of 2022 and 2023. You know that SSC JEE pattern goes as a CBT part 1, CBT part 2. So in the part 1, 100 questions from the technical, 100 marks. In the part 2, 100 questions from technical, which is comprised of 300 marks. So if you see, this is a paper 1. What I'm discussing over here is a paper 1 only. In 2023 on 9th, so October, on 9th October in paper 1, we got 14 questions. On 10th in morning session, 8 questions. On afternoon session, 10 questions. 11th morning session is going to be 6 questions. On 2022 again, so in November 14, in morning session 10 questions, in 15 morning session 10 questions, 15 evening session 10 questions, 16 morning session has 11 questions. See, different sessions have been conducted the same paper due to a huge number of people are appearing for the central level examination. So based upon the time, based upon the availability of the resources, they might have done 2 days or 3 days. But this is about the weightage. If you see on an average, you can expect 10 questions. You can expect 10 questions. So first we have to go to the CBT 1, and once we get qualified, then only we have to go for the CBT 2, computer based test 2, which is completely based upon the civil engineering only. So average, you can expect the average number of questions from the geotechnical engineering is 10 questions. So now let's see what are the different type of questions. I'm taking the previous year's questions only so that you will be understood the level of the difficulty what they're asking. So now let's see the previous year's SSC JEE questions. Come on. So coming to the first chapter itself as the origin of soil. In case of the origin of soils, how the soils has been originated. You see, lacustrine soils are the soils which are depends upon. Lacustrine soils are the soils that got deposited at the bed of the lake. See, based on the natural transporting agents, if the soil is going to be transported by air, we call it as a alone deposit. If the soil is transported by water and deposited at the bed of lake, lacustrine deposit. If it deposited at the bed of a river, alluvial soil. If it deposited at the bed of the oceans, we call it as a marine soil. So with respect to still water lake, lacustrine, and running water river, alluvial soil, and marine water or ocean water, marine soils. Similarly, if the soil is transported by means of gravity, we call it as a colluvial soils. And glacier deposits. For the given question, as they're asking lacustrine, it is transported and deposited in lake beds. So option D is the correct answer. Next, the soils transported and deposited by a river or a stream. Just now I discussed river, alluvial soils. So the correct answer is option D. Next, so that's about the chapter number 1. In chapter number 1, we'll be getting a questions based upon how the soils has been originated and based on the natural transporting agents. Next, in the case of the definitions, relations and properties. You see, a unit phase diagram is normally divided into 3 parts. Yes. So basically, whatever the unit phase diagram or phase diagram, that is divided into 3 parts. And what does the top, middle and bottom part represents? Always the heavier would lies at the bottom, lighter will be at the top. Out of the solid water air, heavier is solid, that is at the bottom, lighter is air at the top, and in between is water. So what is the top, middle and bottom? Air, water, solid. Air, water and solid respectively. The correct answer is option A. Next, a soil sample has a porosity, calculate its void ratio. You know, there is one simple relation between the void ratio and porosity. First of all, what is void ratio? Void ratio represents voids with respect to the solids. In a given soil, how much voids are there with respect to solids is void ratio. And what about porosity? Porosity is how much percentage of voids are there. So, total volume of voids by with respect to the total volume. The relation between the void ratio and porosity is N is equals to E by 1 plus C or E is equals to N by 1 minus N. As given porosity is 25, I can take it as in terms of decimal 0.25. So 0.25 by 1 minus 0.25. So that comes as 0.25 by 0.75. This is 1 by 3. 1 by 3 is a 0.33. From the given options, the correct answer is 0.34. Just simply get down the relation between the void ratio and porosity. Next, A soil has a bulk unit weight of 20 kilonewton per meter cube gamma and water content of 17%. The water content, if the soil particles dries to a unit weight of 19, so now initially water content is 17, their unit weight is gamma. Now if you dry it little bit, then unit weight will decrease. So now the unit weight is 19 and the void ratio remains same. So given that answer rounded to the nearest value, what is the water content? Mind you, as long as the void ratio is constant, you know that gamma D is inversely proportional to 1 plus C. If E is constant, then gamma D is constant. Sir, why we are taking the gamma D, sir? Because there is a relationship between the dry unit weight and bulk unit weight. What is that? Gamma D is equals to gamma by 1 plus water content. Now, as gamma D constant, gamma D1 is equals to gamma D2. Why, sir? As void constant, dry density is also constant. So which means gamma 2 by gamma 1. So from here I can write, this is constant, right? I can write gamma is proportional to 1 plus water content, right? So gamma 2 by gamma 1 is 1 plus W2 by 1 plus W1. So gamma 2 is how much? 19. 19 by 20 is equals to 1 plus W2 by 1 plus W1 is 17%. So in terms of decimal, 0.17. So 0.17. If you solve this, you will get the W2 as 11.15%. 11.15%, so the correct answer is option B. The point that you need to understand, the logic over here is what is the relation between the void ratio and dry density. We have a lot of functional relationships. Say E into SR is equals to W into G. Gamma D is equals to G gamma W by 1 plus C. Those functional relationships are very, very important in the chapter number 2. Next, saturated unit weight of the soil is a ratio. What is mean by saturated unit weight? So gamma sat. Saturated unit weight is nothing but saturated weight of the soil by volume. Total void to saturated bulk unit weight. Total volume to saturated bulk unit weight. No, bulk unit weight of soil when it is a fully saturated. Gamma sat is nothing but gamma at saturation. So it is a bulk unit weight when it is fully saturated. So when it is fully saturated. Next, the mass of a chunk of a moist soil is 20 kgs. So moist soil is natural deposit, W is 20 kgs. And its dry density is given gamma D as 1500 kg per meter cube. What is the void ratio if the soil has a specific gravity of 2.5 and density of water is 1000 kg per meter cube? So now when they give you gamma D, if you want to find out void ratio, the relation is gamma D is equals to G gamma W by 1 plus C. This is very, very, very important relation. If you rearrange, then you can send the 1 plus C to the other side. So G gamma W by gamma D minus 1. Now, what about void ratio? The void ratio is 2.5 into 1000 by 1500 minus 1. So 2.5 into 1000, 2500. 2500 by 1500, so that's going to be like 1000 will get cancelled, 25 by 15, 5 5s, 5 3s, 5 by 3 minus 1. Eventually the void ratio will be like a 2 by 3. 2 by 3 is nothing but 0.667, right? So as it is a percentage, you can write 66.67 percentage. So simply, whenever they give you the void ratio, dry unit weight, you can use this relation. Next, a soil sample has with a specific gravity, G value as 3, mass specific gravity is 2. Assume the soil is perfectly dry. Mind you, whenever we mention the mass specific gravity, the mass specific gravity is completely dependent upon gamma by gamma W. If it is in a dry state, then gamma is nothing but gamma D. So there are two types of specific gravities, true specific gravity, true specific gravity and apparent or mass specific gravity. True specific gravity is always with respect to the solids. Apparent specific gravity is with respect to the state of the soil. As it is a perfectly dry, then represents the gamma D by gamma W, which is nothing but 2. and apart from that G is also given. So what they're asking is void ratio. It is similar to the previous question, right? In the previous question, E is equals to G gamma W by gamma D minus 1. So come on everybody, what is G value? 3. Gamma D by gamma W is 2. Gamma W by gamma D is 2 here. So 3 by 2 minus 1. 1.5 minus 1, the answer is 0.5. So the void ratio, the correct answer is 0.5. Void ratio, correct answer is 0.5. Okay. Next, the total unit weight of the glacial outwash, this is the total unit weight, 5. The water content of the soil is 17%. Find the dry unit weight. So we have already discussed, so the relation between the gamma D and water content. Gamma D is equals to gamma by 1 plus water content. So now gamma D is equals to gamma by 1 plus water content. What is gamma? 5 by 1 plus water content, 0.17. 5 by 1.17, that will give us as 4.27 kilonewton per meter cube. The correct answer is option A. Next, unit weight of soil. See, similar the previous question, just as an example for you. So, as a practice, unit weight of the soil sample is 20, water content is 18. Again, I am asking you the dry density. You can solve this question. So, you can solve this question, you will be getting the answer as 16.94. Gamma D is equals to gamma by 1 plus W. Next, so coming to the index properties of the soil. So, if you see the physical properties, majorly they are asking about what? Properties only. What is the relation between void ratio, porosity, N is equals to T by E, or E is equals to N by 1 minus N. And if they give gamma D, how to find out the void ratio? Gamma D is equals to G gamma W by 1 plus C. Or else one more type of questions you can also expect. So the equations that we used is gamma D is gamma by 1 plus water content. Gamma D is G gamma W by 1 plus C. And there is one more relation, SEVAG, E into SR is equals to W into G. So these are the basic relations on which we can get the questions in case of SSC JEE. Next, so if you see now, in the case of the index properties, let's come to the next chapter, index properties. The limit of water content at which a soil tends to pass from semi-solid state to solid state. For this, we have to understand the consistency chart. If you see, in any soil, if you take a dry soil and if you add the water content and if you look into the volume, initially when the water content is 0, soil is very dry. When the soil is dry, entire voids are filled with whom? Air, right? And at that state, whatever the volume, this is water content 0, at that state, whatever the volume is a dry volume. Now, as you add the water, initially as it is dry, entire voids are filled with air. Now you add water, slowly soil is going to get saturated. Till the moment entire voids gets filled with water, there will be no change in the volume. So till the moment soil gets fully saturated, there is no change in the volume. So by the time it reaches over here, this point, initially at this point water content 0, saturation 0. At this point we added some water so that 100% saturation is done. Entire voids are filled with water. If you add water beyond, then there are no voids left over. So when you add water, that water will be as an extra, volume starts to increases. This is how the consistency chart looks like. And where if you divide this is going to be first a solid state. And as you add water, volume increases means the consistency or the stiffness of the soil will decreases. Then it behaves like a semi-solid. And then it behaves like a plastic. And then finally it behaves like a liquid state. But these states are going to be changes if you keep on adding the moisture contents. So if you observe, there might be some boundary water content where the soil is changing from one state to another state. If the soil is changing from one state to solid state to semi-solid state, that is known as a shrinkage limit. If the soil is changing from semi-solid to plastic limit, that is known as a plastic limit. This is the plastic state. And if it is changing from plastic to liquid, then we call it as a liquid limit. So shrinkage limit, plastic limit, liquid limit are very, 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 very important, and they represent the boundary water content at which the given soil is changing from one state to another. out of which shrinkage limit is the least one, plastic middle, and liquid limit is the large one. So this chart is enough for you to solve a lot of questions. Now, the limit of water content at which soil tends to pass from semi-solid state to the solid state, semi-solid to solid. Whether you add water, if you add water, solid to semi-solid. If you evaporate, semi-solid to solid. So what is that limit? That is the shrinkage limit. Next, the water content where the further loss of moisture will not result in any soil volume reduction. Now, come over here. Just like when I add water, if you remove water, when the water remove, volume also decreases. Up to what point? Up to shrinkage limit. Now you see, up to shrinkage limit, volume keep on decreases, right? If I lower down the water content less than the shrinkage limit, what about the volume? No change in the volume. So the moisture content at which further reduction in moisture content will not cause any change in volume is shrinkage limit again. So from shrinkage limit onwards, you reduce the moisture, it will not cause any change in the volume. Now the correct answer goes as shrinkage limit. Next, the soil moisture content of a clay soil samples were determined for the plastic limit, liquid limit, shrinkage limit. What will be the correct sequence of occurrence of following limits? Correct sequence. Plastic limit is P, liquid limit is L, shrinkage limit. Associated with a decrease in the moisture content. So now I'm not going increasing, I'm asking you decrease. When you decrease, who will come first? Liquid come first, then plastic, and then shrinkage. So in the decreasing order, if you observe, in the order of higher moisture content to lower moisture content, who is higher? Liquid. Who is lower? Shrinkage. Liquid, plastic, shrinkage. So the correct answer is option D. Identify the method that is not used for determination of in situ unit weight. So unit weight we measure by means of core cutter method, sand replacement method, water displacement method. Out of all these methods, the method that is not used for determination is sand bath method. So the sand bath method is used to determine moisture content. Out of the cohesion limits, sticky limit, liquid limit, plastic limit, and shrinkage limit, the most important in engineering practices, obviously, liquid limit, plastic limit, shrinkage limit. We never discussed about the cohesion limit or sticky limit. So the correct answer is liquid, plastic, and shrinkage limit, option B. Next, activity of a soil is a ratio of plasticity index to. The activity of a soil is IP by percentage clay fraction. So this represents how much active the soil. How much active means how much swelling, how much shrinkage the soil can undergo. If this activity is less than 0.75, we can say it as inactive, which means very less swelling and shrinkage. If it is between 0.75 to 1.2, then we can call it as a normal. If the activity is more than 1.2, we are going to call it as a active. So the activity will give you an idea about how much swelling and shrinkage that soil can undergo. So from the given, it's a percentage by weight of the clay fraction, option D. Next, the determination of the plasticity index and the percentage by weight of clay finer than 2 micrometers. Array, what is clay? The soil that is finer than 2 micrometers. Present in the soil were done for 2 soil samples, and the ratio of the plasticity index to the percentage of clay size. What is meant by ratio of the plasticity to the percentage clay index? That is nothing but activity. They simply said that IP by percentage clay. That is nothing but activity is given for both the samples. Now the 2 soil samples A and B are. Just now I mentioned based upon the activity. So now you see here it is less than 0.75, which is going to be inactive. It is greater than 1.2, which is going to be active. If it is in between, we call it as a normal. So the correct answer goes as inactive and active. Correct answer is option B. So that's why this question, along with the details, we can solve this question also. Next, the liquid limit and plastic limit of a clay materials as. So liquid limit is 45%, plastic limit is 25% respectively. What is the activity of a clay materials if 20% by weight of particles of size less than 2 micrometers? Array, less than 2 micrometers means percentage finer than 2 microns. This is nothing but percentage clay. What is this value? This is 20%. And you know IP is nothing but plasticity index, which is liquid limit minus plastic limit. So 45 minus 25, which is 20. Then what is activity? IP by percentage clay. So which is a 20 by 20, the correct answer goes as 1. So the correct answer is option D. Mind you, these are all the previous SSC questions only on one single concept. How many questions have been appeared? Now, a soil sample is tested for its plasticity index again, and the obtained value is at 21. So the IP value came as 21. In such case, the soil sample can be described as. See, if IP value is less than 7, low plastic. 7 to 17, medium plastic. If IP is more than 17, as 21 is more than 17, this is highly plastic. So the soil is highly plastic. So when it is going to be non-plastic, sir, when IP is 0. Medium plastic means 7 to 17. Low plastic means less than 7. When IP is less than 7, low. 7 to 17, medium. IP 0, non-plastic. And whenever the IP is greater than 17, it is highly plastic. Water content of soil can be determined by shrinkage limit method? No, that is to determine the shrinkage limit. Jar test? No, that is for the specific gravity. The sand replacement method? No, that is for the unit weight. And alcohol method? Alcohol method is one of the method to determine the moisture content. So option D. Next. Yeah, so on 26th May, the people that whoever watching now or whatever the video that is going to be get uploaded also. So on 26th May, we are going to conduct a mega mock test for the SSC and every one of the topic will be covered by the teachers or faculty people who have a huge experience. And we are going to cover all the topics, and we made the question paper based upon the previous trends of the SSC. So, and that is going to be an online mode, which is going to be conducted on May 26. You can see the timings as 1 p.m. to 3 p.m. So better utilize this as an opportunity, and this will definitely fetch you a very good thing in the examination. It's going to give you very good knowledge about that, okay? Yeah. Now consider different type of soils: fine sand, homogeneous clay, gravel and silty clay. Arrange the soils in the increasing order of their permeability. So permeability depends upon the size. Larger the size, more the permeability. Out of this clay, first clay has low permeability, low to high, right? And then silty clay, yes. And then fine sand, and then gravel. So CSFG, the correct answer is option C. Which of the following statements about gap grading of aggregates in the true? Gap graded means some particles are missing. Gap graded means some particles are missing. In gap graded, one or more intermediate fractions of particles are absent. Absent are missing. That's the correct option A. How many groups of soil under the Indian Standard Classification System, ISCS? As per ISCS, total 18 groups are there. In those 18 groups, for the coarse grain soils, 8. In the case of the fine grain soils, it is 9. And in the case of the pure organic soils, it is going to be 1. So, yeah, one of our student is asking, a recorded lecture here? No, this is not a recorded lecture. This is a live session. Scroll down, scroll up, scroll up. Mr. Knowledge Adda to all, this is not a recorded lecture. Okay, fine. Yes, very good evening, I think some of the people are joining in between. Very good. So you're an old student. That's nice to meet. Okay. So now let's come to the point. Yeah. How many groups of soils comes under the Indian Standard Soil Classification System is 18. So the correct answer is option D. And now, if you see, which of the following is a method used in the field to determine the permeability of the soil? See, there are various methods to determine the permeability in lab and field, but out of those, the field method is pumping in and pumping out test. So pumping out of well method is going to be the D. Odometer test is to determine consolidation in lab. Falling head and constant head is a laboratory methods, not the field methods. They're asking clearly field. The correct answer is option D. Yeah. So, which of the following factors does not affect the permeability of soil? What are the various factors that does not affect the permeability? You know, K is equals to C into D10 square into E cube by 1 plus C into gamma F by mu. Properties of the pore fluid? Yes, obviously permeability depends upon viscosity of fluid, unit weight of the fluid. Void ratio, it depends. Grain size, it depends. It does not depend upon the total volume of soil. So, permeability does not depend upon the total volume. It's not, they're asking, does not depend. Next, which of the following statements are true about the quicksand condition? Quicksand condition is a type of condition, it's not a type of soil. So, it is only a condition, but not a type of sand. Yes, that's true. It is a condition and type of sand. No. And quicksand condition reaches when critical hydraulic gradient is approximately equals to unity. See, whenever the hydraulic gradient I becomes IC, and you know approximately this value is 1, then the quicksand condition is going to be reaches. Whenever I value is going to be almost equals to 1, then quicksand condition is going to be reaches. Quicksand condition occurs more common in coarse grain sand or gravel than fine sand. No, quicksand condition occurs in fine sand, silt and clay. Quicksand condition will not occur in the higher graded soils. It will occur in low permeable soils, fine sand, silt and clay. So this statement is incorrect. The correct statements are 1 and 3 only. The correct statements are 1 and 3. So if you see, yes, statements 1 and 3 are correct. Okay. Next, a normally consolidated clay layer settled by 20 mm when the effective stress was increased from 25 to 50 kg per meter square. What will be the settlement when the effective stress is increased from 50 to 100? Now it's about the settlement versus stresses. If you recollect, in the case of the consolidation, there is one equation, S is equals to Cc by 1 plus E naught into H into log base 10, whatever the stress, final stress by initial stress. I mentioned you there are a lot of coefficient of compressibility, compression index, volumetric compressibility. So out of all, for engineering practices, we always go for equation related to the compression index. From this, it simply says that S is proportional to log base 10 sigma dash by sigma naught dash. So, which means S2 by S1 is equals to log base 10. If you observe, this is final by initial. When I increase from 50 to 100, I am asking the settlement. So 50 to 100, then finally is 100, initially is 50. By log base 10, initially what is the settlement? The settlement is a 20 mm. When it increases from 25 to 50, 50 by 25. Array, this is S2 by S1, this is 100 by 50, log 2 by log 2. Log 2 will get cancelled, then S2 is equals to how much? S1, which is given as 20 mm. So whenever we want a relation, so whenever we want a relationship between the settlement and stresses, you have to use a relation of settlement is equals to this equation. So this is going to be S2 is equals to S1, which is nothing but 20 mm. Next, CPS analysis. Which of the following, this question comes under, in the case of the consolidation only. Which of the following statements is / are correct? Isochrones are curves of equal pore pressure. No, isochrones are not equal pore pressure. Isochrones are the curves. Isochrones depicts the variation of the pore water pressure along the depth. When time t is equals to 0, the isochrones, so with respect to the depth, U bar is equals to Q, U bar is equals to Q. Everywhere it is going to be same. Sir, then it is a curve of equal pore water pressure, na? No, with the time 0. And when time t is equals to t, the same thing at the top, excess pore water pressure is 0, at bottom 0, but at center it is going to be maximum. When time t is equals to infinity, At the top, bottom and at center also excess pore water pressure is 0. So point number 1. Whatever this isochrone, this representation of variation of excess pressure with respect to depth. That's a true. Statement number 2 is true. Isochrones are curves of equal pore water pressure? No. At a time 0, fine, but not at all other times. Isochrones vary with time? Yes, they are going to be vary with respect to time. So statement number 2 and statement number 3, correct. The correct answer is 2 and 3 only. Next, in a consolidation test, when the load is changed from 50 kilopascals to the 100 kilopascals, the wide ratio change from 0.8 to 0.6, then the coefficient of compressibility. You know there are 3 coefficients: coefficient of compressibility, compression index, volumetric compressibility. Coefficient of compressibility is AV, which is delta E by delta sigma dash. Delta E 0.8 minus 0.6 by 100 minus 50. So which is 0.2 by 50. So in the case of this 0.2 by 50, then if you solve it, that's going to be like 0.004 meter square per kilonewton. The correct answer is option D. The correct answer is option D. Okay. Next. So yeah, please solve this question. Meanwhile, I have some water. Come on, solve this question, please. Okay. So a saturated soil has a compression index. So the compression index is CC 0.28. Void ratio at a stress 12 kN per meter square is 2.05. So void ratio that E0 is given as 2.05. So that stress sigma naught dash is 12 kilonewton per meter square, right? Permeability is given. What is the change in the void ratio if the stress is increased to 21.6? What is the change in the void ratio? This is the question. You know, now the previous question is about the AV, compressibility, quotient of compressibility. Now this is compression index. You know, CC is equals to delta E by log base 10 sigma dash by sigma naught dash. So then delta E is equals to, what is the CC value? CC value is given as 0.28 into log base 10, that sigma dash is 21.6 by 12. Mind you, array 21.6 by 12, 2 is 24. This is 21.6, just less than 2. That comes as 1.8. They have given already log 1.8 is 0.255. 0.28 into 0.255. 0.25 is almost 1/4, na? 0.25 is 25%, 1/4. What is the 0.28 1/4? 1/4 of 0.28 is somewhere around 0.07. So the correct answer is 0.0715. I don't have a calculator, so I'll be going without using the calculator. The correct answer would be 0.07. Okay. So that's the answer. Answer is option A. I haven't got any one of you as a correct answer over here. Nobody has given the answers yet. So the correct answer is about option A. Okay. Next, select the correct option with regard to the following two statements, S1 and S2, pertaining to consolidation in soils. A soil is termed as normally consolidated if the present effective overburden pressure is less than the maximum. Nope. It is normally consolidated if the present stress is more than the any other, and the present stress is itself as a maximum. If the present stress is the maximum stress, then it is said to be normally consolidated. So it is incorrect. The larger the value of coefficient of consolidation, the shorter it takes for full consolidation. Okay, how it is going to be related, sir? Sir, you know TV is equals to CV into T by D square. From here, CV is inversely proportional to T. The larger the CV value, the lesser the time. So the larger the value of coefficient, the shorter it takes for full consolidation to occur. So statement 1 is incorrect. Statement 1 is incorrect and statement 2 is correct. S1 is false and S2 is true. Option C. Next, which of the following is not correct about the effect of compaction of the soil? So now coming to this, compaction increases the shear and bearing capacity, bearing strength of soil. Yes, they're asking not correct. So it increases the shear strength bearing capacity. It increases the permeability. No, compaction will decreases the permeability of the soil. So the correct answer is option B. See the other things. Compaction increases the frictional characteristics. Obviously, when strength increase, friction between particles also increase. Compaction decreases the tendency for settlement. Yes, if you compact, soil will not undergo much settlement. So the correct answer is option B because they're asking not correct. Which type of rollers are most effective for the compaction of sands? For compaction of sands, we go for vibratory roller. In the case of the sheepwood roller, we go for the clays. So for clays, the best suitable is sheepwood. For pneumatic, all type of soils. Smooth wheel roller, this is for the cohesionless soil. So in the case of cohesionless soil, we can go for smooth wheel. In the case of mixed soil, pneumatic. If it is a cohesive soil or clay, sheepwood. If it is a sand, vibratory roller. The degree of compaction is characteristic by means of the dry density. Because when you do compaction, you are going to measure based upon the compaction curve. So you are seeing whatever the maximum dry density you attain, based upon that only you are going to say whether the compaction is good or bad. And by using relative compaction, one terminology. The strength of soil is mainly described as the shear strength. See, in the solid, we say it as a tensile strength. In concrete, compressive strength. In steel, tensile strength. Whereas in soil, it is not compressive, it is not tensile. It is about shear strength. So the strength of soil is mainly described as a shear strength. If the angle of internal friction phi is 30 degrees for a soil, the angle of failure plane relative to the major principal plane in triaxial test. Mind you, whatever the angle of failure plane with respect to major principal plane is alpha f, which is 45 plus 5 by 2. So 45 plus 30 by 2, this will come as 60 degrees. So always do remember, the angle made by the failure plane with respect to major principal plane is alpha f. So the correct answer is option D, 60 degrees. Next, calculate the shear strength in terms of effective stresses on a plane within a saturated soil mass at a point where the total normal stress is, so the total normal stress is 295, pore water pressure is 120, C value is 12, and angle of internal friction is 30 degrees. You know, the shear strength S is equals to C dash plus sigma dash into tan phi dash. C value is 12. Sigma dash is 295 minus 120 into tan 30 degrees. So 12 plus 295 minus 120, which is 175 into tan 30 as 0.578. Okay, so let's consider that 0.578, or let's say that 0.578 as 0.5. So half of this, 175 half, it's going to be somewhere around 87.5. If you take that as a half, 87.5 plus 12, so 99.5, but it's not 99.5. As I take 0.5, 99.5. It is more than that. So answer must be more than that, 99.5. It will not 85, it will not 75. And 135 is too heavy. So the correct answer is 113.15 kilopascals. The correct answer is somewhere 113.15 kilopascals. Okay? Yeah. Okay. So next, a shear box test was performed to give the following results for a cohesive soil. For the cohesive soil, the shear box test, normal stress is given, shear stress is for sample 1 and sample 2 is given. The values, you know, is like CS is equals to C plus sigma tan phi man. There are two unknowns, C and phi. Two unknowns, two equations, substitute. So shear stress at failure is nothing but shear strength. The tau F is nothing but shear strength. So for the first specimen, normal stress is 150, shear stress at failure is 100. 110 is equals to C plus normal stress 150 into tan phi. The second specimen, 120 is equals to C plus 250 into tan phi. So if you do 2 minus 1, 120 minus 110, 10, CC will get cancelled, 250 minus 150, 100 into tan phi. So then what is the tan phi? The tan phi value is 0.1. Tan phi value is 0.1. That's it. I don't go for other things because 0.8, 1.2, 1, 0.1. The correct answer is option D. So the tan phi value, so it is going to be simply 10 by 100, which is a tan phi is 0.1, and then you substitute the remaining, you will get down the C value. The correct answer is option D. The correct answer is option D. Okay. The determination of the shear strength of a soft saturated clay deposit. So in the field, see, out of all the methods, the field test is nothing but the vane shear test. Triaxial test, unconfined direct shear test, there are the laboratory methods. The field test is a vane shear test. A retaining wall with a vertical back retains a mass of cohesionless soil. Surface, active lateral earth pressure coefficient in terms of phi. The angle of intersection is given as. What is the active lateral earth pressure, which is nothing but Ka, which is a tan square. 1 tan square 45 minus phi by 2 or 1 minus sin phi by 1 plus sin phi. So K is equals to 1 by tan square 45 plus phi by 2 or tan square 45 minus phi by 2 or 1 minus sin phi by 1 plus sin phi. So from the given options, the option is, answer is option B. Now, an excavation is to be made in a saturated soft clay, so where the phi value is given as 0 degrees. What will be the maximum unsupported depth? The maximum unsupported depth is nothing but HC, which is 2 times of the tensile crack depth ZC. So which is a 4C by gamma root Ka. Just now we have seen about the Ka value. So whenever the phi value is 0, K is equals to 1. As phi 0 degrees, Ka value 1 minus sin 0 by 1 plus sin 0. It becomes 1. So which is going to be 4 into cohesion as 30 by gamma as 15 into root 1. So now it is going to be like 8 meters. The correct answer is option D, which is 8 meters. Okay. Now, for a certain soil, the angle of internal friction is how much? 30 degrees. Quotient of active and passive earth pressure, man. When phi is equals to 30 degrees, you substitute, the Ka value is 1 by 3 and Kp is equals to 1 by Ka. That's the reverse of the Ka, that's going to be 3. So 1 by 3 and 3, 0.33 and 3. The correct answer is option B. In a rigid footing on a coastal soil, the contact pressure distribution is rigid footing on a coastal soil. So when the footing is rigid, in case of the rigid footing, the settlement is going to be uniform. Settlement is going to be uniform. Whereas contact pressure, if it is a clay, in case of the clay, in the case of the clay, at the edges strength is more, so contact pressure is also going to be more in case of clay at edges than at the center. So this is how the rigid footing on the clay soil. So with the contact pressure is more at the edges. It is a non-uniform. Yes, contact pressure is non-uniform with the maximum at the ends and minimum at the center. So the correct answer is option A. If they would have asked about the settlement on the rigid footing, if they would have asked settlement, then the answer would be uniform. And if they would have asked for the sand, in the case of sand, at edges strength is less. So contact pressure is less at edges, more at the center. Then answer would be at the B. So type of footing changes, answer changes. Soil changes, answer changes. According to Terzaghi and Peck, the ratio of D15 of the filter to D85 of base, this must be less than or equals to 5 ray. This must be less than or equals to 5, but from the given option side is going to be, we can take it as less than 4. So this must be less than or equals to 5. Why, sir? Because when you see the filter and base, we have to allow the water to go out, not the filter particles, so that the filter size must be less than or equals to 5 times of the base size. In a standard penetration test, what is the weight of the hammer and the drop height? Weight of the hammer is 63.5 kilos. Height of fall is 75 centimeters. So 75 centimeters is 750 mm. So 63.5 and 750 mm. Which of the following type of foundation is best suitable in case of expansive type of soil? For expansive type of soil where the swelling and shrinkage is very high, it is better to go for the under-rimmed piles. Under-rimmed piles are the not vertical piles, they are the bulb piles. So they are made by means of the boring only, they cannot be done by means of the precast driven. There is a bored pile, there is not a driven pile. This bulge portion, this will help in preventing the swelling and shrinkage. So which type of soil, which type of foundation is best suitable for expansive soils is under-rimmed piles. Observed N value of SPT is 21, then what is the N value after correcting the dilatancy? See, whenever the N value is more than 15, then the corrected N value, actually this N value we have taken as a overburden. First we need to do the overburden correction and then dilatancy. But as they have not given any data, we can directly do the dilatancy correction. So that corrected value will be like 15 plus N recorded. Whatever this recorded is 21. So minus 15 by 2. 15 plus 21 minus 15 by 2, which is going to be 18. I say simply, whatever this value, 21, if it is more than 15, 15 plus how much excess is there? 21, 15 to 21, 6. Out of the excess, you take only half. Repeating again, 15 plus, what is the half of the excess value? So from 15 to 21, excess is 6, you take only half, 3. 15 plus 3, the correct answer is 18. So that's the option D. And with this, we are done with whatever the concepts regarding to the geotechnical engineering. I hope you understood all the concepts. We have done a lot of questions and we covered a lot of questions in between. So all the best for your examination. Don't forget, on May 26 there is a mega mock test. I wish you all the best for that examination, and I'm pretty sure that it will be very much helpful for your preparation towards the SSC JEE 2024. All the very best, and if you have any other doubts, you can contact me, you can message me through that. So I'll be very happy to give a reply to you. All the best.